Hello everyone, welcome to my channel. If you are new to my channel, please subscribe to my YouTube channel, so you can join our tech family. If it is informative to you, please like our video, share it with your friends so they can get help with these video, and don't forget to press all notification bell icon so you get regular update and don't miss any single video.
You might have heard of spanning tree. This is a very important process that runs between our switches and helps to keep our network stable. In this video, we're getting a brief overview of what spanning tree does, and in the next video, we'll see how it actually works. Picture this. You have a small network with one switch and a few devices connected. Perhaps some workstations, printers, and a router connected to the internet. As the business grows, you need to add more equipment, so you add a second switch. This is, of course, connected to the first switch. This is all still one single VLAN and one subnet at this point. We're just increasing the number of available ports. Now let's say we grow a bit more and add a third switch. Of course, we'll want to link this to our other two switches. This is still all one VLAN and one subnet, just extra ports that we can use. It might not be obvious, but this presents us with a problem. Consider what happens when a device on the network sends a frame to the switch. You'll remember from earlier videos that switches learn MAC addresses of connected devices, so it knows exactly where to send these frames. Broadcasts, however, are a bit different. They are sent out all switch ports on the VLAN, except the port the frame was received on. This includes links to other switches. Do you see the problem that we might face here? Take a look at what happens to the broadcast frame. The switch forwards the frame out of each port, including the uplinks to the other switches. These switches forward the frame out their ports too. The broadcast frame begins looping around the network indefinitely. Remember that frames operate at layer 2, not layer 3 like packets do. There's nothing built in at layer 2 to stop frames from looping around. But surely that's not too bad, right? A frame loops around for a bit, it can't be that bad. Look what happens when we add a fourth switch. This causes a single broadcast frame to be duplicated many times, each one looping around indefinitely. What if we now add more hosts to the network? Even with just 4 hosts, this is getting out of control. Of course, with 4 switches, we could have 100 hosts, and a 4-switch network isn't even all that big. We call this a broadcast storm. These frames will continue to loop and duplicate until the switches can't handle any more traffic. At this point, the network grinds to a halt. It's a pretty big problem now, isn't it? This is where spanning tree protocol comes in. This is a relatively old protocol developed by Radia Perlman in 1985. It is a process that runs on every switch, detects potential loops, and strategically disables certain links, making the network loop-free. But you may be wondering, why bother cabling up these extra links if spanning tree is just going to block them anyway? Well, there are 2 reasons. Firstly, spanning tree is clever enough to select the most appropriate link to block, which might not be the one you are expecting. Second, if we lose one of our switches or other links, spanning tree can re-enable the blocked link, repairing the network. The key points to remember right now are: spanning tree works at layer 2. Layer 2 does not have any built-in loop prevention. Layer 3 does have loop prevention. This is the time to live field in the IP header. Here you can see the benefit to really understanding the lower levels of the OSI model. This doesn't seem too hard so far, right? But this has been a simple topology. A complicated topology is where spanning tree really earns its money. Have a look at this network, which to be fair isn't really overly complicated. Here we see several loops. Once again, spanning tree goes through the topology and finds the loops. It will then select the most appropriate link to disable, eliminating the loop. The most appropriate link is usually the slowest link. So if you have a mixture of fast and slow links, then the slower links will be disabled. This has been an extremely high-level introduction to spanning tree protocol. In the next and final video of this series, we'll look at how spanning tree operates in some more detail. Hope to see you there.
We hope you enjoyed the video and found value in the content. We value your feedback. If you have any questions or suggestions, feel free to post them in the comments section or contact us directly by our social platforms. Thanks for watching.